the last lecture we were saying defining arguments for the for the functions. Just as a reminder, so when we define functions, we can also provide them some arguments, some data to do some actions to process it, and then, like as in this example, we define a number argument in which we multiply it by 2, and then we print the results. And then once we define our function definition, then we can use it and provide any value to that function, and then it will process it, and then process based on based on our definition. And what we have seen is we had covered also this slide. Now we were here. So when we are defining functions, we can also define multiple functions. As in this example, we have this show sum function in which we provide two different arguments, and then we take the average of the summation of them, and then we print it. And then when we are calling this function again, now we have to provide two different values here. And note that now the syntax is basically the def, the function name, and then within the parameters, parentheses, sorry, the variable names, but we put a comma in between to show that, to separate those parameters. And when we are calling the function, like as in this example, we said that, okay, 12 and 45, then the order of the document is important. Like, so this num1 will be 12 and num2 will be 45 when we call this one. The order is important. Let me show it in this example. Maybe in a summation operation, the order is not important, but let's say that we defined a subtract operation, which in which we take two numbers, and then we can say that, okay, let's just print num1 minus, this is num1 minus num2. So this is our function, just this. And then when we call this function, if we say subtract and then 5 and 3, okay, and if we also say subtract 3 and 5, then the numbers will be, of course, different. Like what we will have is 2 and minus 2. How we get it? Like we say, okay, 5 and 3. So Python is thinking in this way, like it is just looking at the order of the parameters. So num1 is the first one here, and num2 is the second one. Then the first number, which is 5, it should be num1, and 3 is the second number, so it should be num2. So 5 minus 3 is will give us this result 2. But when I just change the numbers, the order of it, like 3 and 5, then num1 will be 3 and num2 will be 5, and the result will be 3 minus 5 minus 2. So in short, we can define multiple arguments in the function definitions. Each of them is separated by a comma, but the order of the arguments is important because Python understands it in that way. Shall I proceed? Any questions so far? All right. And this part is important, maybe a bit technical part of it, which is, so we define the functions with the parameters, which means that we give them some data to process it, and then whatever it will do. But the question is our function will be affected by that? So is our data, will be affected by the operations done in the function? Like thinking in this way, I have a car, and then I give it to my friend he will just drive it. And then he makes a crash with the car, and then he brings it back. Okay, this is your car. So simply, like, I have a data, I give it to my function to process it. And then when I got my data back, will it be the same one, or will it be a different one? Like the car, it's crashed. No, my friend might say, okay, I just painted pink or so, whatever it is, or will I get the car that I gave it to him? So similarly, like, what is the impact of functions on our data when we call them? Here is one example for this. So we can also write it here. I'll take them in parentheses comment, so I want to see the results there. There's the results. All right. So let's say that we have some data in which we can say that, okay, num variable is 50, okay? And now we have also some function f, which takes some argument. And in that one, maybe it will say that, okay, it is trying to change the data. Like, it's not only using it, it is changing it, okay? So let's say that it will make it, okay, I would like to set it to 20, okay? Then it will print, okay, within the function, a is equal to this one, okay? Then, so I will basically call my function, this f function, with this num variable. I would like to know, okay, so this function f took my data, which is 50, and then and try to change it to 20. What happened if I try to run it after I call this function? After function f, a is basically, let's see, okay, so this is not a, sorry, this will be num. This will be num. I would like to also put num here, okay? So let's see. All right. So let me run this code. So what is saying, as you can see now, within the function, num is equal to 20. After function f, num is still 50. So it didn't change it. The changes that it does within the function only affects here, only the function itself, but not outside the function. So basically, yeah, I give the car, and then he crashes the car, he changes its color and so on, but when I get the car again, well, it's the same car that I give it to it. Similar that it doesn't have any impact on our original data. So this is called, how is this possible? So basically, when I have this data, here I have this num data, and then when I'm calling this function f with my data 50 num variable, it's not giving the original one. It's not giving the memory location. So this num variable is basically stored in the memory in some place. It's not giving that memory location to my function. It's just giving its value. It's just giving 50, and so that it can do whatever it wants. But when I'm trying to access that data again here, I will be able to access to the original data that I have. So this is the main idea, and this is called pass by value. So I would like you to memorize it. This is actually a term. In some other languages, it might be pass by reference. Then it means that it will change the data. But in Python, now we have this pass by value, which means that, in short, functions does not have any side effect on our data. All right. Do you have any question on this? The other one is keyword arguments. As I said, that in Python, the order of the parameters are important. So when I call this summation function, this is the subtract function here that we did here, the order is important. The Python understands, okay, what will be 5 and which one will be 3 based on the order. But there's also another way to do this, and I would like to show it with another example. Let's say I have this, again, let's define another function. This is a simple function. It will just take 3 arguments, okay? And it will just print them, okay? Print A, print B, and print C. So when I'm calling this function, this message function, if I give it to 1, 2, 3, it will print 1, 2, 3. I would like to put here another message just to separate the codes, okay? So it will just print 1, 2, 3. If I just said, okay, print 3, 2, 1, so I just changed, but still what will happen is now A will be now 3, B will be 2, C will be 1. So when I print it, now I will get 1, 2, 3, 3, 2, 1. So the order is important. But what I will do is with this keyword argument, there is also another possibility. What I can also run it is, okay, A will be 1, B will be 2, and C will be 3. So this is also, I can also do it in this way. So when I run this code, well, it will basically, A is 1, B is 2, and C is 3. So this is how it can be done. Here I need to know the order in this, but here I need to know which name I used in my function definition. So I used A, B, and C. So I should say A, B, and C here. And the good thing with the keyword arguments is that now I can change the order, because now I can also say, okay, now C will be 3, A will be 1, and B will be 2. Okay, so the order is changed. Here it was A, B, C. Now it is C, A, B. But then, sorry, as you can see that the results are same, 1, 2, 3, 1, 2, 3. So when I'm using keyword arguments, the order is not important. I can just write them in order, because Python knows that, okay, if we already tell it, okay, C will be 3, B is 2, and A is 1, you can give it in n order. But here, when we don't give any name, it forces you to follow the order of the arguments that we defined. There's also one more thing, which is I can also use both of it, a combination of it. What it means is, like when I'm defining the function, I can use some of them as a positional argument, like I don't give name 1 and 2, and then the other one will be, let's say 3, but in that one I'm using a keyword one. So C is 3, 1, 2, and C is 3. So this is also valid, and this will also give me exactly the same result. As you can see here, it's still 1, 2, 3. So because what Python is doing is that, okay, the first one, okay, no name, so it should be the first one, A is 1. The second, no name, so then it should be also the second one, B is 2, and I'm just saying C is 3. So this is, it can still understand it. And I can, now for this one, I can just use, like, maybe I can also even say this, like A is 1, so B 1, and B is 2, and C is 3. So it will give me again the same result. So this is also valid. Since I can also do it, like, since now these are arguments, keyword arguments, I can change their order, like 1 and C is 3, B is 2. The result will be still same, 1, 2, 3. But there's one thing that we cannot do when we are using this mix of arguments, which is when I'm calling the function, I would like to say, okay, B is 2, C is 3, and 1. Okay. When I'm trying to run this, as you can see that I'm getting an error. I'm getting an error because when you are using both, Python forces you to say, okay, the first ones should be always the positional ones. So you cannot put 1 here and the keyword ones at the beginning. Well, you might say, okay, isn't it so easy? Like, you have 3 parameters. I already said B is 2, C is 3. So 1, what can it be? It should be A, right? So any reasonable person will understand, okay, A should be 1. But unfortunately, the computers are not smart, as I said previously. Like, they said, no, I have no idea what 1 is. Like, okay, I understand B is 2, C is 3, but what is 1? So this is what Python is saying. So that's why we really have to follow their rules. So, and then it will not run at this point. So we can write it in these ways, but not in this way. All right. Do you have any question about this concept? Let me check if I miss anything here. No. So just some more examples if you would like to see. Turtle.write function. So we give the first one as a positional argument, and then the other one is with a keyword argument which says align is center. Or we have this reverse name function. We have this first and last, and then it prints it in the reverse order. when I'm calling it, I can for the reverse name function, I can also use these keywords to say that last will be my last name variable, and the first argument will be the first name variable. So we can do it in all other functions. Shall I proceed? Any questions so far? All right. The other topic that we need to say is the global variable. But first, before the global variable, what we had seen before was the local variable. So what is a local variable? A local variable is basically the variable that we defined within a function that we had seen in the last lecture. So a local variable is only accessible within that function. If we try to access it in another function, in another place, like this one, we have this name, but we are trying to also use it here, then we will get an error. So this was the local variable. But then what is a global one? Well, in a global one, so we define a variable not inside any function. So like as in this example, we have this my value is 10, but it's not within a function defined. It is above the functions, outside the functions. Now this becomes a global variable. What it means is I can access it in all other function definitions, like definition show value, and then I'm saying print my value. So I'm able to access it. I'm able to use it in all other functions that is. So it's globally accessible. It's not local. So this is what the global variable means. And there's one thing that we need to be careful about it. Like when you want to access it and just use it, don't update its value. You can just use it as it is. But if you want to change its value, then we need to be a little bit more careful, because as in this example, now we are saying, okay, number is 0, okay, and then I would like to change it, okay, to like I'm asking enter a number to the user and convert it into integer, and I will keep it to my global variable. In order to do this, I first need to say that, okay, global number, global as a keyword. Then I will be only able to change it. Why is this? Well, if I don't put it, if I don't say, okay, global number, Python will consider it as this number as a local variable, and it will just redeclare another variable named also number. But here when we say this, what we are saying is Python, no, I don't want to recreate another, I don't want to declare another variable. I meant the variable that we defined above. So this is what number is, then I can only change it. So to recap, if you want to access it, just use it. You can use it as you like. But if you want to update a value of a global variable, then you should say that, okay, first you should say that it is the global number within that function definition. Is there any questions so far? Is that part clear? So you can write it from scratch. If we ask any question, you'll be able to write it. Good, then I'm moving on. Global variables are valid, so you can use it, you can define it in any place, but it's not highly recommended. Like, use it only when you really have to do it. Why is this case? Well, let me show it in one example. I'd like to put this also in comment. Okay. So if we have any a global variable, global number, okay, is 10 or so, and then if we, which means that we can use it in any function, like in function f, I can use it in function, another function. Maybe I would like to change it, so I would like to say it is the global one. It's the global number, and then I would like to change it to 5, and then I would like to print it, and so on and so. So when we have this kind of a global number value, global variables, the thing is, when I call this function f and m, the result will be like 10 and 5. Sorry, but I'll call it again here. Yeah. So what happened is I just called function f and then m and then f. So the output of the f function is just changed because of the function m. So they are so depend on each other. I define different functions, but they are affecting their results, their output. So this is something that we would like to avoid because it will make harder to read our code. So when I'm reading this code, okay, I need to follow what is happening to the global number because it is accessed in many different places. I need to be sure that, okay, if it is really producing the output that I'm expecting. So it will make our code harder to read, which also means that it will be easier for us to do mistakes, which we don't want it, of course. So because of this, avoid as much as possible of using these global variables. But you can, of course, do it like if you really need a variable that should be accessible in all functions, then of course you can define it. But it will reduce the readability of your program, which might cause some problems, because the code will be more sophisticated, so you can do unintentional mistakes. So it's better to avoid using them. And a global constant. So what is this part? Let's remind. Let me ask you: do we have constant variables in Python? Do you remember that?
Yes,
but we can change it. Yes. So in other languages like Java, for instance, you can define a constant variable, which means that when you try to change it, Java will not allow you to change it. The program will not run if you attempt to change it. But in Python, we don't have it actually. We just say that, okay, we define, okay, this is global, but actually, this is constant, but it is actually, Python will not force you not to change it. You can change it if you want. So actually, that's why what we are doing is we are just simulating that it is like a constant. So we are just saying, okay, I made this constant, so I should not change it. And in order to, so we remind ourselves, okay, we just follow the programming tradition, like the constant variables should be all uppercases. So I'm writing this all uppercases just to remind me that, okay, this is meant to be constant. I shouldn't change it. And also, when you make it a global constant like this, like I define it here, this contribution rate, all uppercases, I can still change it. But the good thing, I can use in all functions, and I can change it. But in order to really change it, I also need to say global contribution rate, and then I can really change it. So I need to be, if you don't want to change it, then yeah, if you don't put this global contribution rate, then it will not change our constant value. But in reality, yeah, Python will not force you, will not prevent you to change it if you really want to change that.